So in this section, we will talk about transformation of the graph of a function. Okay, so here we will do a graphing of a function. Okay, now let's start with the basic function. And so the very first basic function will start from a linear function. So for example, if we have a function f of x, just let me call it f. So if we have a function f of x equals to x, okay, so here our x is the input, okay, and this input x has an exponent 1. This is a linear function, and whenever we have a linear function, what is the type of graph we get? We always get a straight line. Okay, so if we have a linear function, then the graph of our linear function is a straight line. And so in this case, we have a straight line, let's say passing through a origin. Okay, so we did not need a points here. So in this section, we need to know what is the shape of graph for a given function. Okay, so without plotting, this is a linear function, so the graph is straight line. Now the next function, for example, if our function f of x is equals to x squared. Now what's the difference here? So we have a input x, but the difference here is that this x has exponent 2. Okay, so we call this square function, or we can also call it quadratic function. And this square function or a quadratic function has a graph, and that graph looks like, does anyone know what is the graph of a quadratic function? It's a U-shaped, okay, parabola. So we have a graph that's a U-shaped. So every quadratic function, not only this one, okay, so every quadratic function has a U-shaped graph, and we call that parabola. Okay, every linear function has a straight line as a graph. So this is our second basic function. The next basic function, so we have a f of x equals to absolute value of x. This is absolute value function. Okay, so we have an absolute value expression here. So this is absolute value function. And what is the shape of a graph of an absolute value function? It's always V-shaped. Okay, so the graph of a absolute value function, we get a V-shaped. Okay, this has to be straight line here. So let's draw V-shape here. So this is the graph for an absolute value function. So every absolute value function has a V-shaped graph. Okay, so this is the next type of basic function. Now the next we have, if our function f of x is square root of x. So this is square root function. Okay, so if we have a square root of x as a function, then our graph looks like it starts from 0. Okay, this graph starts from 0 and it goes like this. Okay, so this is a graph for a square root function. So every square root function has a graph that is very similar to this one. Not exactly, okay, but they looks very similar. So we have a linear function here, straight line. We have a square function, parabola. We have an absolute value function. We have a square root function. Now let's take the next function. If our function f of x is equals to x cube. What do we call this function? Cubic function. Okay, x has an exponent cube. So this is a cubic function, and if you have a cubic function, the graph of a cubic function is, so we have a graph and that looks like, okay, so our graph looks like this. Okay, so this is the case when we have a cubic function. So this is the graph for every cubic function. Okay, Okay, then the next type of basic function we will be talking here is, this should be the last one. So if we have a function f of x equals to, let's say we have a function f of x equals to 1 over x. And what do we call this function? What is 1 over x? It is a rational function, okay? So this is a rational function, and if we have a rational function, our graph looks like, so we draw a graph, our graph looks like this. It has to be smooth curve, okay? So our graph looks like this. Let me redraw this one. And we have one more graph here, and we call this hyperbola, okay? So this is the case when we have a rational function. So whenever we graph a rational function, so this is the shape of every rational function, okay? So these are the graph for a basic function. Now in this section, we will use this shape of a basic function, okay? So we'll use this basic function to graph a new function, okay? We will always start from this basic function. We graph the basic function first, okay? Then we move or we transform those basic function and try to get a graph for a given function, okay? So every one of you is required to know this shape of basic function. So you have a graphing calculator, you can use it, okay? Or if you know like a straight line, if you have a graph and that is a straight line, you should know this is a linear function, okay? We always start from a basic function. So make sure to know the basic function here, graph of a basic function here. Okay, now let's go to the next topic here. So if we have a function, okay, so okay, let's start with the example here. So we have a function f of x equals to absolute value of x. Now at first, what type of function is this? So what type of function is f of x equals to absolute value of x? This is a absolute value function. So let's start by drawing a graph for this basic function. So this is our basic function, f of x equals to absolute value of x. This is our basic function, and the graph of this basic function is V shape, okay? The absolute value function has a graph V shape, okay? So you draw V shape at origin. Make sure you are drawing at origin. Okay, you do not need points here. You just need the shape of graph, okay? This is the absolute value function, so we draw V shape. Now, so here we have a new function g of x, okay? Our basic function is f of x equals to absolute value of x. Now our target is getting g of x, okay? So our target is getting g of x. What should we do? So we are starting from basic function, okay? Now to the basic function we can add numbers, we can subtract numbers, multiply, divide, or replace, okay? Now this is what is given to us. So f of x equals to absolute value of x. Now if we want to get absolute value of x minus 2 from this basic function, what do we need to do? So find the differential. So in between these two, what is difference? Or how can we get g of x, okay? It means how can we get this expression, okay, absolute value of x minus 2 from absolute value of x. What difference do you see there? So how can we get absolute value of x minus 2 from absolute value of x? We subtract 2, right? So when we subtract any number from a function, okay, then our graph is shifted vertically downward by 2 units. Now, so every time, okay, if we subtract any number from a function, then we move that graph vertically downward by that number. Okay, so to get a graph of g of x equals to absolute value of x minus 2, okay, so we get this function by subtracting 2 from a basic function. It means we move our graph vertically down by 2 units. Okay, so this is -1, -2. Now we move this graph, okay, exactly same graph vertically down by 2 units. So let's draw v shape at -2. So we draw v shape graph, we shift. Okay, so this is where we started, and we move this graph vertically down by 2 units. Okay, and that graph is our g of x. So this is our g of x equals to absolute value of x minus 2, and this is our f of x equals to absolute value of x. So whenever we subtract any number, okay, from a basic function, means we are shifting graph vertically down by that number. Okay, so since we subtracted 2 from this basic function, we move the graph of a basic function vertically down by 2 units. Now in the similar way, if we add any number to a function, then our graph is shifted vertically up by that number. Okay, for example, let me call h of x. Okay, so let's say we have h of x, and our h of x is absolute value of x plus 3. Okay, so this is the basic function. F of x is our basic function, and in the basic function, if we add 3, we get our new function h of x. Okay, now to get the graph of h of x, what we do, we shift our graph of a basic function vertically up by 3 units. Okay, so let's move this graph of a basic function up by 3 units. So 1, 2, 3. So we draw v-shaped graph at 3. So this is our h of x, absolute value of x plus 3. So adding a number to a function means you are moving your graph vertically up. Subtracting a number from a function means you are moving your graph vertically downward. Okay, so this is the vertical shift of a function f of x. So yes.
Is there any way that the graph can move horizontally?
Now there is a horizontal shift in our next topic. Okay, but here, so if you are adding any number to a function, make sure you are moving graph vertically up. If you are subtracting any number to a function, you are moving your graph vertically down. Okay, now the next one is horizontal shift. Okay, so here, so we have a function f of x equals to absolute value of x. Okay, same function. So f of x equals to absolute value of x. This is our basic function. Okay, so this is the basic function. Let's draw a graph of a basic function, and our target is getting a graph or drawing a graph of a g of x. Okay, so let's start with a graph of a basic function. Our basic function is absolute value of x. It means we have a v-shaped graph. So you draw a v-shaped graph at origin. So we have a v-shaped graph at origin, and this is our f of x equals to absolute value of x. So we always start from a basic function. Okay, and you draw the graph of a basic function. Now our target is from a basic function. This is what is given to us. So using from a basic function, we have to get a g of x. So we have to get g of x equals to absolute value of x minus 2. Now how can we get our g of x equals to absolute value of x minus 2 from this expression absolute value of x. What should we do? Do we add a number? Do we subtract a number? Divide, multiply, replace? What do we need to do to get absolute value of x minus 2 from absolute value of x? Do we subtract what? Okay, subtracting. So if you subtract 2 means you, okay, now if you, okay, we have this expression. Okay, subtracting 2 means absolute value of x minus 2. Now, are these two exactly same thing? So if you subtract 2 means you get absolute value of x minus 2. It's not same. Now, how can we get absolute value of, so how can we get absolute value of x minus 2 from this one? The only way to get that is we replace. Okay, so here we replace this x by x minus 2. So if you replace x of a basic function by x minus 2, we get g of x. Do you agree? So this is what we have, absolute value of x. In order to get g of x, we replace this x by x minus 2. Okay, if you replace this x by x minus 2, we get our g of x. Now, what does it mean in the transformation? How our graph shift? So, if we replace x of a function, okay, replacing, okay, not adding or subtracting. So, if we replace x of a function by x minus some number, then our graph is shifted horizontally to the right by this unit, by 2 unit. Okay, now we move this graph on the right by 2 unit. 1, 2 is here. So you draw V shape at 2. So you draw, okay, let me use a different color here. So you draw V shape at 2. So replacing x of a function, okay, replacing x of a function, it means we are moving our graph horizontally. Okay, so if you replace x of a function by x minus any number, it means you are moving that graph on the right by whatever number you use. Okay, if you replace by x minus 4, then you are moving this graph on the right by 4 units. Okay, if you replace x by x minus 10, then you are moving that graph on the right by 10 units. Yes. Now, if it's positive, now if you replace x by x plus some number, then you are moving on the left side. Okay, so let me take different function. Let me take h of x. Now, this h of x, let's say we have absolute value of x plus 4. Now, to get this function, we have to replace x by x plus 4. Okay, and replacing x of a function by x plus 4 mean we are moving the same basic function graph. Okay, we are moving basic function graph on the left by 4 unit. Okay, 4 unit on the left. -1, -2, -3, -4. So you draw V shape at -4. Okay, so we draw V shape graph at -4. And this is a graph for our h of x equals to absolute value of x plus 4. So adding a number to a function means you are moving up. Subtracting a number from a function, you are moving down. Now, this is the case when we are replacing, not adding, not subtracting. Okay, so if we replace x of any basic function, it means we are, if we replace x by x minus some number, it means we are moving on the right side. If we replace x of a function by x plus some number, means we are moving to the left. Okay. Now, and this applies for any basic function, okay, not only absolute value function. So let's do some more example. And let's see if we have here. Okay, let me take different example here. For example, let's say we have a function and we have to graph a function f of x equals to square root of x plus 2. So for example, we need to graph this function, okay? So we have a calculator, we can use that to check your final answer, but in this section we have to use the transformation, okay? To graph this function we have to use the transformation. Now the very first step here is that what is the type of function? So how many type of function we did as a basic function? So in our basic function, we had a linear function, we had a square function, we had an absolute value function, square root function, cubic function, and rational function. So these are the type of function we had. Now out of those function, what type of function is that? That's the very first step here. So what is the type of function? This is square root, or this is square root function, right? And if we have a square root function, then the basic function will be, so what is the basic function? So let's go back here. So if we have a square root function, then our basic function is f of x equals to square root of x. So let's write down that basic function. So our basic function is f of x equals to square root of x. So first step is we have to find out the type of function, and once you have a type of function, you can know what is the basic function. So let's draw a graph of this basic function, and you should know the graph of this basic function even without using our points here, okay? This is a square root function, and the square root function has a graph that starts from origin, okay, and this is a graph for our basic function f of x equals to square root of x. Find the basic function, okay? Once you have a basic function, you have to draw the graph of a basic function. Now we move this basic function, okay? We will try to get our this function square root of x plus 2. Let me call different name. Let me call it g. Now, so we are starting from this basic function. In order to get this g of x from our basic function, what do we need to do? Do we add, subtract, or replace? So you have square root of x, and you want to get square root of x plus 2. Now, how do we get that? So we have, so this is what we have. You have square root of x, okay? Now, from this square root of x, our target is getting square root of x plus 2. Now, how do we get that? By adding 2. Now, what does it mean by adding 2 for a basic function? Are we moving left, right, up, down? We are moving up by how many unit? 2 unit, okay? So, we move this basic function graph up by 2 unit, okay? So here positive 1, positive 2, so we draw exactly same graph at 2. So we draw exactly same graph at 2, and this is our g of x. So this is square root of x plus 2. So we used our basic function graph, okay, to get a graph of this g of x. So whenever you are adding any number, then you are moving your graph vertically up, okay? Now in the similar way, if we had, okay, let me call, we have a new function h of x, and h of x is square root of x plus 2, okay? Now is g of x and h of x exactly same? Is this g of x and h of x exactly same? These are different, okay? So here we have square root of x plus 2. Now what do we have here? We have a square root of x plus 2. Now, we start from a basic function. Okay, our basic function is same, f of x equals to square root of x. Now from this square root of x, how can we get this square root of x plus 2? Do we add, do we subtract, do we replace, or what do we do to get square root of x plus 2 from square root of x? Replace. Replace what? Replace x by x plus 2. Now here we replace x of a function, so we replace x of a basic function by this expression x plus 2. Now what does it mean in the transformation? How our graph shift when we replace x of a basic function by x plus some number? Are we moving left, right, up, down? Left by how many units? 2. Okay, so we are using basic function. Okay, so we use the basic function graph. So you move this graph on the left by 2 units. So this point is at 0. So let's move this point on the left by 2 units. So you draw exactly same graph on the at -2. Okay. Now if you wanna be have like a pretty accurate graph, you can find the y-intercept of this function. Okay. So finding y-intercept means we replace x by 0 and we get the square root of 2. And square root of 2 is 1 point something, right? So you draw very similar graph at -2. Okay, so you get a graph like this, and this graph is h of x plus 2. So if you replace your x of any basic function by x plus some number, means you are moving graph on the left by that number. Okay. Now in the similar way, if you have next function p of x, and if p of x is square root of x minus 5, then how do we get this expression from absolute value of x? We subtract 5. Subtracting 5 means we are moving basic function graph vertically down by 5 units. So this is our graph for a basic function, -1, -2, -3, -4, -5. So you draw the same graph at -5 for p of x. So you draw the same graph, and this is our p of x. So subtracting a number from a function means you are moving down. And the next one we had is, so let me call q of x, and if you had q of x as a square root of x minus 5, okay, you make sure these two are different here. Okay, so to get this q of x, we have to replace x by x minus 5. So we have to replace x by x minus 5 by this expression. And replacing x of a basic function by x minus 5 means we are moving the basic function graph on the right side by 5 units. So 1, 2, 3, 4, 5. So at 5, you draw a graph very similar to the basic function, and this is our q of x. Okay, any question up to here? Yes.
What if our x was a negative? What would happen?
That is a different type of transformation. Okay, that's something we have should be in page 3.
Okay.
Okay. Now this transformation will be provided on your formula sheet. Okay, you do not need to memorize. Like when you add a number, we move up, right? So when we subtract number, we move down. So this transformation will be given on your formula sheet. Okay. And when you replace x by x minus some number, you are moving on the left. If you replace x by x plus, sorry, if you replace x by x minus, you are moving right. If you replace x by x plus some number, you are moving left. Okay. So the transformation will be given to you on your formula sheet. Okay, but you should know how to apply this one. Okay, so let me add one more example and I want you to practice that, okay, before we go to the next type of transformation. Now, can you graph f of x equals to x cube plus 2, okay, and g of x equals to x cube minus 3, h of x equals to x minus 2 cube, and q of x equals to x plus 2 cube. Now we have a 4 different function, okay, and I want you to graph this function. Now the very first step is we find the type of function. What type of function is this? We call it cubic function, right? Now if we have a cubic function, what is its basic function? We should know that basic function. So if on our very first topic, so if we go back, so what will be the basic function for all this function? All these are a cubic function. So what is our basic function? F of x equals to x cube, right? So our basic function, so let's write down our basic function. So let me call this 1, 2, 3, 4. So our basic function is f of x equals to x cube. Why f of x equals to x cube? Because every function, all these functions are a cubic function. Okay, because of that, our f of x equals to x cube is a basic function. Now let's graph this basic function. So you should know how to graph this basic function, okay? You can use your graphing tool, okay, graphing calculator to graph this basic function. So the graph of this basic function, cubic function, look like this, okay? So here it passes through origin, okay? So it's not a straight line. Okay, so this is a graph for our basic function. So let me write down that this is f of x equals to x cube. Okay, any question up to here? Finding the type of a function, identifying the correct basic function, and drawing a graph of a basic function. Okay, now in number 1, let's see what we are asked. So in number 1, we are asked to graph f of x equals to x cube plus 2. Now, we are asked to graph f of x equals to x cube plus 2. You compare with basic function. So you have x cube. From x cube, in order to get x cube plus 2, what do we have to do? Do we add, subtract, or replace? Add what number? 2. Adding 2 means what do we do to the graph? We move this graph vertically up by 2 units. Okay, so we add a 2 means we are moving the graph vertically up by 2 units. So this is 1, this is 2. So make sure you, let's move this point. Okay, so we draw very similar graph at 2. Okay, so this is our number 1 graph for a function number 1. Okay, so for number 2, we subtract 3, right? It means we are shifting, we are moving this basic function graph vertically down by 3 units. What about for number 3? How do we get a graph for a number 3? By moving our basic function graph on the left, right, or up, down? On the right by 2 units. What about number 4? How do we get a graph for a number 4? By moving this basic function graph on the left by how many units? 2 units. Okay, so I want you to complete this one, and remaining we will do in our next class.